Hello everyone, welcome to this new video tutorial. My name is Zoran. As a cloud solution architect, I excited to guide you through creating an Azure Landing Zone using Bicep for infrastructure as code and Azure DevOps for automation. Each step will build scalable, secure environment with resources like storage account, key vaults, app service, etc. Many people have asked me whether they use Azure Landing Zone or continue with Azure Blueprints. My response is, of course, you can stick with Blueprints, but the Landing Zone offers a range of significant benefits. An Azure Landing Zone serves as a pre-configured, scalable, and secure setup, streamlining workload and resource deployment in Azure, ideal for cloud migrations. For this project, Bicep, a domain-specific language from Microsoft, has been selected for defining Azure infrastructure, valued for its simplicity integration, alongside widely used options like IRM JSON and Terraform in commercial settings. Language choice hinges on project goals. Bicep and IRM for native Azure support, Terraform for multi-cloud capabilities, or Bloomy PowerShell CLI for scripting needs. Now let's explore the scenario. As a cloud solution architect hired to migrate e-commerce companies' infrastructure to Azure, the focus lies on crafting a robust landing zone for their online store, incorporating automated deployments and incremental enhancements. We will need core Azure services, virtual networks, storage accounts, app services, key vaults, log analytics workspace to drive this transformation. A modular approach with Bicep comes into play. Utilize main.bicep file at the subscription level to create resource group, calling modular Bicep files for each service as shown on the slide, all scoped to the resource group. A perimeter.json file provides flexible values like location and names to support this migration. Video splits in two parts: manual landing zone deployments followed by automation with DevOps. Let's get started to see how actually this works.
The project kicks off with a setup in a folder named c/landing zone on the local machine. This name ensures organization and avoids tool-related path issues, serving as the root for all files. At the core lies main.bicep, crafted in the root of c/landing zone. This file acts as the entry point, defining the structure at the subscription level. Let's take a look. The target scope is set to subscription to create zoranresource.rg, requiring subscription level access. Parameters such as location, default to East US, resource group name for the RG, add flexibility. The resource section builds the RG with module calls for governance, networking, security, storage, app, and monitoring. Each module aligns with the scope, resource group, open parenthesis, rg.name, close parenthesis, and depends on, ensures orderly deployment, like networking following governance. This code orchestrates the modules to shape the landing zone. Next, parameters.json emerges in the root folder. This file passes values to main.bicep without hard coding, enabling adjustments for various setups. It includes validation schema content version and parameters like location set to East US, resource group name to zoranresource.rg, working with deployment commands to provide the values. A module subfolder is then created within c/landing zone to organize the code. Each module, a separate Bicep file, handles a specific landing zone component, enhancing reusability. Governance.bicep in the modules folder establishes compliance. With a resource group scope and allocation parameter for future flexibility, it defines a policy assignment enforce encryption, linking to a built-in Azure policy for storage encryption, maintaining a secure environment. Networking.bicep follows, building the virtual network infrastructure. Also under resource group scope with a location parameter, it creates a virtual network prod VNet with an address space of /16 and a subnet web subnet at /24 laying the networking foundation for ops or VMs. Then, security.bicep handles security resources. Using the same resource group scope and location, it builds a key vault, prod vault with a standard SKU, soft delete enabled, and no initial access policies, ideal for storing keys and secrets securely. Storage.bicep defines the storage account. Taking location and storage account name parameters, it constructs MyStorageZoran1 with a standard LRS SKU, storage v2 kind, and encryption enabled, delivering reliable data storage. App.bicep supports app hosting. It sets up an app service plan with a free tier and an app service linked to it, demonstrating web application hosting. Lastly, monitoring.bicep configures monitorings. This file establishes a log analytics workspace prod logs for logging and alerts, keeping the environment observable. To bring the Azure Landing Zone setup to life, the Azure CLI steps in as a fantastic tool for managing resources directly from the command line. Let's start by running command to compile all the Bicep code into a deployable ARM template. This process transforms the modular main.bicep file and its modules into a single ARM file. And let's check out the generated main.json file to see the compiled output, ensuring everything is set for deployment. Note that main.json serves as a reference to review the structure, not required during the actual deployment. Now let's move on and execute a zdeployment sub what if to preview the deployment plan. This helpful command reveals how the system plans to create the Zoran resource.arg resource group and all the associated resources, such as the storage account, key vault, and app service. Take a look at the output, which provides a clear breakdown of each resource, including their names and configurations, offering a handy roadmap before proceeding. Next, let's go ahead and deploy the solution with the zdeployment sub create, passing the main.bicep and parameters.json files. This command brings the entire landing zone to life in Azure, constructing the resource group and deploying all the defined resources smoothly. After that, look in the Azure portal to verify the results. Under Resource Groups, you can see the new resource group, Zoran resource.arg, is created. Here is the storage account, MyStorageZoran1, the key vault, prod vault Zoran, the app service, e-commerce app Zoran with its plan, prod plan Zoran, the virtual network prod-vnet with its subnet, and the log analytics workspace prod logs. Seeing everything in place is a satisfying moment. Validating that the Bicep code and CLI commands work together perfectly to build the foundation for the e-commerce platform. With the manual deployment complete, let's transition to phase 2, where the same process is replicated using Azure DevOps for enhanced efficiency.
With manual Azure Landing Zone deployment successfully in place for this e-commerce company's migration, the focus shifts to the showcase in Azure DevOps, which brings distinct advantages. DevOps delivers automated deployments through the pipelines, enabling entire landing zone to be deployed with a single action, saving variable time as the e-commerce platform scales. Version control with Git becomes available, facilitating management for updates and consistent infrastructure. Team collaboration thrives with DevOps, allowing the multiple architects to refine the modules and integrate changes seamlessly. Smooth rollback process with Git ensures the ability to restore a previous state effortlessly when needed. This efficiency drives the decision to highlight Azure DevOps. Let's explore this approach together.
To automate the process, a new project named Landing Zone Project is created on dev.azure.com. In VS Code, a Git repository is initialized in c/landing zone. With Git init, all files are added with Git add and committed with Git commit. The connection to the DevOps repository is established using git remote add origin with the URL, followed by a git push to sync the Bicep files to the cloud, setting the stage for automation. Now, let's set up the pipeline. Navigation to Pipelines, New Pipeline, begins the process, selecting the repository and choosing Starter Pipeline. In the YAML editor, the pipeline is defined with a trigger on the master branch, a pull using Ubuntu latest, and a step section featuring an Azure CLI at a toTask. The code includes trigger, master to initiate the pipeline on pushes, pull, image, Ubuntu latest to set the agent, and the Azure CLI at toTask to execute a Z deployment sub create with main.e bicep and parameters.json. The pipeline is saved as bicep deploy pipeline, paving the way for the next step. To connect to Azure, a service connection is established. In Project Settings, Service Connections, the New Service Connection option is selected, choosing Azure Resource Manager and App Registration Automatic. The connection links to the subscription is authorized and named My Azure Connection. This setup enables the pipeline to authenticate and deploy resources securely to the subscription, ensuring a smooth integration. After connection is created, I added connection string in my pipeline file and run the pipeline. Pipeline run the job and finished in 3 minutes. So, my Azure resources was recreated again, only I was forced to change key vault name in my Bicep script, because previously delete process didn't delete key vault name. I just added number 2 in existing name prod vault Zoran 2.
After successfully developing this Azure Landing Zone using Azure DevOps, now let's explore an incremental update. An incremental update modifies or adds new features, configurations, or resources to an existing setup, ensuring that the core system remains intact and operational. For my project, an incremental updates means modifying main.bicep file to add a storage container, mycontainer-zoran, to the existing mystorage Zoran account resource, and redeploy them. The Azure deployment process recognizes that existing resources like e-commerce app Zoran are unchanged and only applying the new additions, keeping the landing zone stable and scalable.
To demonstrate incremental deployment, a storage container.bicep file is created in the modules folder, adding a blob storage container mycontainer-zoran to mystorage zoran1. The main.bicep file is also updated to include this module. Changes are committed with git commit and pushed with git push. The pipeline triggers again, successfully adding the container and showcasing the ease of expanding the landing zone. Verification occurs on the Azure portal under Resource Groups. Zoran resource.rg, confirming my storage Zoran1 now includes my container Zoran. Now I am going to clean up all created resources, ensuring no costs remain. A cleanup task is also added to the pipeline for future runs, enhancing maintenance efficiency.
The journey concludes with successfully creating Azure Landing Zone using Bicep and DevOps delivery scalable environment with incremental service additions. This highlights the power of infrastructure as a code. Thanks for watching. Feel free to leave the questions and comments, and I look forward for our next video.